Get started in just a couple minutes. All right, good morning, everyone. Today we're going to be doing a little bit of an activity in probability. So it's usually a fun one. Hopefully you'll enjoy it. So first of all, I just want to remind you that your math review assignment is due this coming Monday, August 31st by 11:59 p.m. So if you haven't done that already, you'll want to go ahead and get started with that. Remember, this is the only assignment that is graded based on completeness. So as long as you go ahead and show all your work and complete it fully, you will be in good shape for those points. The rest of your assignments will be graded based on correctness. So for this one, even if you don't get it correct, you might want to go ahead and just make sure when I show you the answers, just make sure you understand everything, because these are the core mathematical principles you'll need throughout the course. Okay. Also, your first homework assignment will be posted by September 4th and is due on Monday, September 14th by 11:59 p.m. Okay, so let's get into the material for today, and it's based on what we talked about in lecture 2 that you hopefully already looked at. By the way, lecture 3, I just posted it this morning, so it is available for you now, okay? On YouTube, of course, where everything else is. So first of all, we talked about in lecture 2, rock, paper, scissors is the game fair. And so most people are familiar with rock, paper, scissors. You got your rock, closed fist, paper, flat palm, scissors number 2 horizontally. Each player hits the other hand twice, and on the third time gives the symbol that they wish. Okay, and rock beats papers, and paper beats rock, and scissor beats paper. And if you both pull the same symbol, then it results in a draw. So, is this game fair? Is this game fair? And we can address this question using the power of probability. And so you see that player A might throw a rock, paper, or scissors. Player B also might throw a rock, paper, scissors. Player A is in red, player B is in blue. And so we can see that there are 9 possible outcomes, right? Just looking across the cells, we see 9 total. And so what's the probability of any single outcome? Well, any one outcome would be 1 over 9, which if you did that division is 0.1111. Repeating. Okay, so again, this is all from lecture 2, so I'm not going to belabor it too much, but you can always pop in with questions on the chat feature if you'd like to do so. So then we go ahead and we label each outcome as player A wins, player B wins, and draw. So we shade the cell red if player A wins, blue if player B wins, and yellow for a draw. And you can see we wind up with 3 red, 3 blue, 3 yellow. So what's the probability that player A wins? Well, we use our rule of probability and we see that there is 3 successful outcomes over 9 total outcomes. So 3 over 9 or 1 over 3 or 0.3333 repeating. Same for blue, 3 over 9, 1 over 3, 0.3333 repeating. And same for yellow, 3 over 9, 1 over 3, 0.3333 repeating. Okay, so in each case there's a third or 33% chance that you're going to win, lose, or draw. So what does that mean about the fairness of the game? Is the game fair? And I would argue, yes, it actually is fair. And why is it fair? Because we have an equal chance of winning and losing. Simple as that, right? If you enter into a game, you want to have a good chance of winning, good chance of, well, you really want to have a good chance of winning, but to be fair, we'd want it to be equal chance of winning, losing, and that's what we have here. Okay. So then I just started to introduce you to the game of rock, paper, scissors, lizard, Spock. And let's do that one more time.
I'll tell you what, how about we go rock, paper, scissors?
Ew, I don't think so. Anecdotal evidence suggests that in a game of rock, paper, scissors, players familiar with each other will tie 75 to 80% of the time due to the limited number of outcomes. I suggest rock, paper, scissors, lizard, Spock.
What?
Oh, it's very simple. Scissors cuts paper, paper covers rock. Rock crushes lizard, lizard poisons Spock. Spock smashes scissors, scissors decapitates lizard, lizard eats paper, paper disproves Spock, Spock vaporizes rock, and as it always has, rock crushes scissors.
Okay, I think I got it.
Rock, paper, scissors, lizard, Spock.
All right, so that is rock, paper, scissors, lizard, Spock. And as you can see for this game, we have, once again, rock is a closed fist, paper a flat palm, scissors is the number 2 horizontally, lizard is the sock puppet mouth, and the Vulcan salute for Spock. Okay, so this time you hit the other hand 5 times, and on the 6th time you give the symbol you wish. And then you can see how it works in terms of all these options. Okay, where scissors cuts paper, scissors decapitates lizard, those sort of things. Okay, so is this game fair? And what we're going to do here today is assess the fairness of this game using an experimental approach. So in a few minutes, I'm going to pair you up with someone else in the room using Zoom breakout groups. If you've not used that before, basically what it does is it separates everybody into different rooms. I'll put either 2 or 3 of you in a room. I'll try and put as many of you into rooms of 2 as possible. I think there'll be probably 1 or 2 threes. Okay, so we'll do that. You're going to identify one person as player A and the other person as player B. You're going to play rock, paper, scissors, lizard, Spock, and I'll give you those rules again. You're going to play that game 15 times. And you're going to record the outcome for player A and then choose someone to report back to class. So in other words, you're going to play this game 15 times. Like I said, I'll give you the rules again. you're going to track what happens to player A. How many times they win, how many times they lose, how many times they draw. And then when you come back, hopefully you'll say something like won 3 times, lost 5 times, draw 7 times, right? Something like that. Okay, so that's the idea here. Here is the rules again, but what I learned when I was teaching this before is that once I break you out into groups, you don't get to see the slide anymore. So once I break you into groups, I'm going to send a message to everybody with all the rules. So stay tuned. Just give me a minute to do it. And once I break you out into groups, I'll send you a message with all the rules. Okay. And if you have any questions once you're in the groups, please let me know. Then we'll come back and we'll talk about how we actually did. Okay. So let me go to breakout rooms here. Okay. I think we're good. Okay, I'm going to open all rooms and then you can join them. Okay. If you haven't done so already, please go ahead and join your rooms. And I'm going to send you a message shortly. Gabriella, there should be something there that would allow you to hit join and then you could join the breakout room. If you're struggling, you can let me know. just another minute or two, and then we'll get back to this. All right, welcome back, everyone. Hopefully you had a chance to get through that activity. So now what we're going to do is record some results. So I'm going to go ahead and do a new share and share with you the whiteboard. And I'm going to add some text to this whiteboard where we're going to record our wins, losses, and draws. Okay, so for, let me just move this up just a little bit. For breakout room 1, would you please tell me what you had for player A in terms of wins, losses, and draws?
Okay, I think that was us. So we only got a chance to do 14 instead of doing 15. Is that
Okay.
okay?
Yeah, that's fine.
We had, wait, we had, player A had 1, 2, 3, 4, 5, 6, 7, 8, 9. She had 10 wins
Okay.
and 4 losses.
And no draws.
No draws.
Okay, perfect. Thank you.
Thank you.
And then how about breakout room 2?
So player A had 4 wins, 5 losses, and 6 draws.
Perfect, thanks. I know breakout room 3 had some technical difficulty, so we're going to skip that and go on to breakout room 4, please.
Player A had 5 wins.
Okay.
Player B had 4 wins.
Okay.
And then there were 6 draws.
Perfect, thank you. So how about group 5, please?
So there were 9 wins,
Okay.
4 losses, and 2 draws.
Perfect, thanks. So we're up to breakout room 6, I believe.
I just had a question. What happened with Scissors and Spock? Who won there?
Scissors and Spock. Let me double check. Gosh, how does that one work? Because Spock disproves paper, but how does anyone remember? I'll check back if not. Give me 1 second,
I
sorry.
think Spock beats Scissors. And then Scissors kills Lizard, and then Lizard wins.
Yeah, Spock smashes Scissors. Spock smashes
Okay.
Scissors.
Then player A had 4 wins, 8 losses, and 3 draws.
Perfect, thank you. Um, Group 7, please.
We had, we're only talking about player A, right?
Yeah, only player A.
Okay. 4 wins and 11 losses, and then 0 draws.
Okay, perfect. Thanks. Group 8, please.
5 wins, 3 losses, and 7 draws.
Wow, okay. Thank you. And finally, group 9.
We had 5 wins,
Okay.
6 losses, and 4 draws.
Perfect. Thank you. Okay. So, let's go ahead, and what we want to do next is figure out what was the probability or what was the chance of winning, losing, and drawing in each group. So what we're going to do is sum up the wins, sum up the losses, and sum up the draws. So I'll sum up the wins for everybody. Would someone else please volunteer to sum up the losses? And I have a chat here. Hang on one second. Oops. Okay. Well, right. Okay. Perfect. So yeah, I just need a volunteer to sum up the losses, please.
I got 45.
Oh, you did it already. Okay, perfect. Thank you. I really appreciate that. So 45 for the losses. Thank you. And then would a volunteer please sum up the draws? And I'll sum up the wins in the meantime. So let me just go to my calculator here. Okay. So for my total, I got 46. I'm sorry, would you mind repeating what the losses was again?
45.
45, thank you. And did anyone get the draws yet?
28.
28? Perfect, sounds good. Okay, thanks. So for our grand total then we have 46 plus 45 plus 28, which is 119. So now let's figure out the probability of winning, losing, and drawing. And of course, the way we do this is we're going to take 46 divided by 119, and we see that it's 0.386, actually it's 0.387 if I round up, so 38.7% chance of winning. Let's see about losing. That's 45 divided by 119, which is about 37.8% or 0.378. And then finally, let's figure out the draws. 28 divided by 119, which equals about 23.5% or 0.235. So based on this data, 38.7% of the time you win, 37.8% time you lose, and 23.5% time you draw, what do you think? Fair or not fair? Anyone have a thought they want to share? Okay. Well, while you're thinking about it, let me share with you my opinion, which is I would say this game's pretty fair based on our data, right? You win and lose about an equal percent of the time. I mean, it's not perfect, but it's pretty close. Whereas you draw a lot lower percent of the time, but that doesn't bother me very much. As long as you're winning and losing about the same percent of the time, I'm pretty happy. So now let's return. Let me do a new share here, if I can, and return to our little slideshow. Great. And then we ask ourselves the question, can the fairness of the game be assessed by the results of a single pair? And I'd say probably not, because you all got very different answers, right? It might have been 10 and 4, or it might have been 4 and 10 and 1, or it might have been 6 and 5 and 4, right? So we probably can't assess the fairness of the game by the results of a single pair. Now, can the fairness of the game be assessed by the combined results of the entire class? Well, actually, in this class, you guys did pretty well. I'd say probably yes. But, you know, in the last class I ran this, they got 30%, 47%, and 24%. So they were really got a biased result. So we have to be careful about that. Can we always assess the fairness assessed by the combined results of the entire class? Kind of depends. And if we want to improve our assessment of the fairness of the game, what would we do? Collect more data. As opposed to having you guys run this game 15 times, maybe you'd each play it 30 times or 50 times or even 100 times. The more data we have, the more likely we are to get the right distribution, the one that would actually be suggested by probability. Okay. So now let's consider actually figuring this out using probability. So we went from 9 outcomes before to how many now? I see 5 down by 5 across, so 25 total. And of course now the player A can throw the red rock, paper, scissors, lizard, Spock, and the player B can throw the same options except they're in blue. So now how many possible outcomes do we have? 25. What's the probability of any single outcome? 1 over 25, or 0.04, or 4%. So now let's do the same thing we did before with the shading. And let's go ahead and shade in where player A wins with red, player B wins with blue, and a draw with yellow. And so if you did some quick counting, you would notice that there were 10 times that red won, 10 times that blue won, or player B won, and 5 draws. So now if we do that math, 10 over 25 gives us 0.4, or 40% of the time player A wins. Again, 10 over 25, 0.4, 40% of the time player B wins. And 5 over 25, or 0.2, or 20% of the time you have a draw. So you guys actually came pretty close to the real results of 40%, 40%, 20%. Now can we say the game's fair? Again, I would argue yes, because you have an equal chance of winning and losing. And as the character Sheldon, who was teaching the game, pointed out, the advantage of rock, paper, scissors, lizard, Spock is that you have a much less chance of drawing than in your standard rock, paper, scissors. Okay. Questions about that? Okay, if you have any questions, please feel free to stick around and ask them. Other than that, I'll wish you a great weekend. Don't forget about the math review, and we'll check in again on Monday. Have a great one.
Thank you.
Thank you.
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 Have a
Thank
good one,
you.
guys.
I actually had a question.
Sure, please.
I was wondering, do you post the slides under QL?
Yes. So I'll post the the actual slide you mean from the lectures, right?
Yeah, I was trying to copy down some of the tables, but I just missed a couple of them.
Yeah, no problem. I will post the videos. So like from today, I'll post the whole video so you can just scroll through and figure out what you need.
Okay,
And then
perfect.
the slides are posted with the actual lectures, of course, the content lectures, right? Yeah. So yes, I will post these.
Okay, thank you. And my only
Of
other
course.
question, the second question, you said something about it being 4%. It was like after the how many outcomes?
Oh, 1 over 25 is 4%. So if there's only, what's the probability of any single outcome? So if there's 25 outcomes, then 1 over 25, probability of any single outcome is 0.04 or 4%.
Gotcha. Thank you.
Okay, absolutely. Have a great weekend.
You too. And I like the
Okay.
game, by the way. I used to always watch Big Bang, so I was like,
Oh, good. I'm glad you liked it. Cool.
yeah.
All right.
Come on.
Okay, you too. Bye.